Dark we rise and soar, guided by the dreams we wore. From the oceans to the skies, endless fire burns in our eyes. Beyond the stars we chase the light, with fearless hearts through endless nights. No frontier can hold us down, the universe is our playground. Mountains high and oceans deep, secrets in the void we keep. Every step a tale to weave, for those who dare, who still believe. Beyond the stars we chase the light, with fearless hearts through endless nights. No frontier can hold us down, the universe is our playground. Is our playground. Mountains high and oceans deep, secrets in the void we keep. Every step a tale to weave, for those who dare, who still believe. Beyond the stars we chase the light, with fearless hearts through endless night. No frontier can hold us down, the universe is our playground. Echoes call from far away, guiding ships through cosmic sway. With every launch a new sunrise, the quest for knowledge never dies. Beyond the stars we claim the skies, bound by hope that never dies. To worlds unknown we'll make our mark, light flames within the dark.
Three, two, one.
Light AIT phase.
The Spaisat NG program has been a very good example of institutional and industrial collaboration. In the industrial part, it has been a very good collaboration between the two main industries in Europe, being AIRBUS and Thales Alenia Space, including all the Spanish industries in this important program.
Airbus works to safeguard Europe's citizens and strategic autonomy. Through Spaisat NG, it will provide secure, resilient and flexible communications for those who keep us safe.
T-minus 4 minutes, 26 seconds and counting. We've just heard the call out, strong back lower has begun. It's actually a sequence that'll start with the clamp arms beginning to open. You'll see those right now in the monitor. You can see the arms are on the top of the second stage. We open those in preparation for the strong back pulling away from the rocket. And you can see the arms coming open now. Next up will be retract of the strong back. Now the transport erector we talked about has two components, the strong back that runs alongside the Falcon 9 and a launch mount underneath. The launch mount under the Falcon 9 has the 4 hold downs that release at T0. The strong back along the side is hinged to the launch mount, and it will rotate right now about 2 degrees away from the vehicle, and you can just start to see that motion beginning. Now at liftoff, the strong back will then move to a position 45 degrees away from the Falcon, and that clears the way for launch of the launch vehicle. Completing the recline. Now at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of the kerosene fuel and liquid oxygen. First stage loading should complete here momentarily. We're waiting for the call out. And then about a minute later, second stage of liquid oxygen loading should complete. Now the white clouds...
Stage 1 LOX load is complete.
Stage 1 LOX load complete. We're on time. We're down to one more tank to finish loading. Stage 2 LOX. The white clouds that you're seeing around the vehicle, they're formed as the chilled gas vents overboard to maintain pressure in the tanks as needed. Current temperature at the launch site's a balmy 63 Fahrenheit, 17 Celsius. And when the gas meets that warm Florida air, it condenses the moisture in the air and it forms those clouds. As we wait for T-minus 2 minutes and the start of the second stage LOX closeout, a few more things that'll happen in the last part of the countdown. At T-minus 60 seconds, Falcon 9 will be in startup. That means the rocket's autonomous internal flight computers have taken over the launch countdown. There are computers on both the first and second stages.
Stage 2 LOX load is complete.
LOX load complete on second stage. That means the 1 million pounds propellant is completely loaded now on both the first and the second stages. Next major activity is going to come up at T-minus 1 minute 30 seconds. That's going to be the ground gas closeouts. We'll begin venting pressures in the strong back overboard. Make sure everything is drained in preparation for launch.
Gas launch closeouts has started.
There we go. The gas closeouts have begun. Next major event will be T-minus 1 minute. As I mentioned, the Falcon flight computers will go into startup. One comment, I mentioned there were flight computers on both stages. During ascent, the second stage flight computer is the master. As we count down at T-minus 2 seconds, we'll begin the Merlin 1D engine ignition sequence. The flight computers will command the hold downs to release at T0.
Falcon 9 is in startup.
Falcon 9's gone into startup. The flight computers are now controlling the launch vehicle. Falcon 9's looking good. Spaisat is ready to go. Falcon 9 team's working no issues. The weather is excellent. The range is ready.
Launch director, go for launch.
And the launch directors go for launch. Let's listen in to the flight of Spaisat NG1.
T-minus 30. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, liftoff. Go SpaceX, go Spaisat NG1. Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
T-plus 30 seconds, Falcon 9 has successfully lifted off from Complex 39A at Kennedy Space Center. We can hear the characteristic rumble as the first stage heads into space. We're throttling down right now in preparation
Power and telemetry nominal.
for max Q. Good call out, power and telemetry nominal, reports avionics.
Falcon 9 is supersonic.
And we have throttled back up to power.
Max Q.
And we've heard the max Q call out. Continuing on the timeline, everything looking good. The rocket typically will need to go 17,000 miles per hour horizontally in order to get into orbit and avoid being pulled back down to Earth. To help go from vertical to horizontal, the first stage performed a pitch kick just after liftoff, about 10 seconds into flight, or what's also known as a gravity turn. The engines gimbal a small amount, and that slowly turns the first stage from going straight up to going horizontal with the help of gravity, and eventually we will be roughly horizontal to Earth as we achieve orbit. Now you can track the progress to orbit by keeping an eye on the left side of your display. That's showing the first stage velocity and altitude, and then we'll have displays for the second stage as we get past stage separation. Now we're going to have coming up in about 30 seconds the start of the typical 3 quick events. Main engine cutoff, or MECO, you'll hear the call out. We'll shut down the 9 Merlin engines on the first stage. The pneumatic system, the stage separation pushers, will then push the first stage away from the second stage for stage separation, and the MVAC-D engine will ignite, and then fairing separation. For now, let's listen and watch for the events.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
And there you heard and saw those events that happened back to back to back. We had main engine cutoff, stage sep, and second stage engine start number 1, SES1. Right-hand side, you can see the altitude and the velocity of the second stage. So far, I want to remind folks who might be waiting for it, as we talked about earlier in the webcast, the first stage will not be recovered today. You may have noticed that we removed the landing legs and the grid fins to decrease the mass of the stage. That'll provide the performance needed to put the 6 metric ton spacecraft into orbit. The legs and fins can be used on other boosters. But now we want to say to the first stage,
Fairing separation confirmed.
Fairing separation on time. And for first stage that is on its way back to Earth, not for recovery, farewell, and we thank you. Now the fairing halves that you just saw separate from around the Spaisat NG-1 spacecraft, we'll be attempting to retrieve those halves once they fall back to Earth using our recovery vessel Bob. Now the fairings will orient themselves as they come back down with gas thrusters for entry into the atmosphere, and as they near the ocean, each fairing half uses a gas-powered deployer to release a parachute. The fairing computer will send commands that steer the fairings to the ocean landing, where the recovery vessel Bob will attempt to recover them. Now we've got a few minutes until our next major event, SECO-1, which is where we'll shut down our MVAC-D engine on the second stage in the parking orbit.
Stage 1 FTS has safed.
Coming up on 5 minutes, everything continuing to look good. You can see the orange-red glow of the niobium alloy nozzle extension on the second stage engine. Very standard for the MVAC-D engine. Five minutes, everything continues to look well, look good. Now you'll notice the speed continuing to increase on the display for stage 2. That speed is obviously increasing. That's because the acceleration is going to increase throughout the burn. The thrust of the MVAC-D engine, just over 220,000 pounds of thrust in vacuum, stays constant during the burn. But as we burn off the propellant, the mass is decreasing. And so for those who remember force equal mass times acceleration, if the force is constant but the mass decreases, the acceleration is going to increase. For this first burn, the stack will be doing about 3.8 G's acceleration as we get to SECO-1. T plus 6 minutes, continuing to look good on the second stage. Spaisat NG-1 attached to the top of the second stage. We'll see some views from the forward-looking camera.
Vehicles on a nominal trajectory.
A little later on. The GNC, the Guidance, Navigation, and Control Engineer, calling out the nominal trajectory for the stage. 6.5 minutes into flight, continuing to look good on the burn. Next major event's going to come up a little bit after 7 minutes. We should hear a call out of terminal guidance on the second stage as we begin to get ready for shutdown at T plus 8 minutes and 1 second.
Stage 2 is in terminal guidance.
There's the call out from GNC. Second stage flight computer is now moving into a state where it's preparing for that second stage engine cutoff. We're calculating the velocity required to get to orbit. You have to understand how fast you're going horizontally as well as away from the Earth. And then we have to come up with the commands that are going to go to the actuators so that we can command pitch and yaw to make sure that the second stage aims itself, so to speak, to achieve the desired orbital parameter. Now, final velocity for this first burn is aimed for about 7.5 kilometers per second. That's going to be just under that 17,000 mile an hour figure we need for a low Earth parking orbit. And 7.5 kilometers per second, that is the rule of thumb for the velocity you need to get into an Earth orbit when you're launching eastwardly, for example, out of Kennedy. Shutdown of the MVAC, we're going to wait for guidance to tell us how the orbit looks.
Nominal orbit insertion.
And confirmation, nominal orbit insertion. We're through second stage engine cutoff number 1, SECA 1. We're right where we want to be in orbit. Now, the second stage, and we've got another nice view looking forward from the payload attach fitting up at Spaisat NG1. We'll have more views as we go through the webcast, but for now, we're embarking on a coast phase on the second stage, spacecraft still attached. Following this coast, we will relight the MVAC engine for a second time. That's going to happen around T plus 26.5 minute mark. And then about 4.5 minutes after that, at T plus 31 minutes, we will actually get to spacecraft separation. For that, we're going to halt the live commentary for a while. We'll be back in about 16 minutes at T plus 25, but we'll leave you with the visuals from space.